You know, when you look behind like a really complicated older entertainment center.
Oh, yeah. The rat's nest.
Exactly. You've got the TV, the gaming console, the sound system, the router, and behind all of those expensive screens, it is just a terrifying dusty tangle of black wires.
Right. And it's the kind of setup where, it functions in the short term,
Yeah.
but the second you try to upgrade a single component, the whole system just collapses.
Yeah, you reach back there, you pull one cord, hoping to unplug a lamp or something, and suddenly the Wi-Fi goes out and the TV restarts.
It's a total nightmare.
It really is. It's a system where everything is technically connected, but you have absolutely no idea how the underlying logic is routed.
Mm.
And, well, that fear of the tangled wires is exactly why React's architecture matters so much.
Mm-hmm.
So, welcome to today's deep dive. We have a massive stack of technical notes here, and our mission today is to unpack a comprehensive guide to React architecture.
Specifically focusing on how React components manage data and share logic.
Right. We're going to compare some really foundational design patterns. So we're talking controlled versus uncontrolled components and how the classic higher-order components stack up against modern custom hooks.
And, the reason you should really care about this as someone building complex web apps is because choosing the right pattern dictates whether your code base remains a clean, maintainable joy to work with, or if it becomes that tangled, buggy mess behind the TV.
Totally. So let's look at how to stop the bleeding in your component tree, starting with the biggest culprit of messy data, which is forms.
Forms are just the perfect entry point for this discussion because they represent the boundary between your user and your application state.
Right.
Before we can even talk about sharing data cleanly across a massive application, we have to look at how we capture that data at the source. And architecturally, there is a fundamental tug of war happening right at that boundary.
Yeah, it really comes down to a battle over the single source of truth. Like, are we letting the browser's document object model the DOM manage the state, or are we forcing React to take the wheel?
Exactly.
Let's start with the approach most developers reach for first, the control component. In this pattern, React completely hijacks the native HTML behavior, right?
It does. I mean, mechanically, you are shifting the memory allocation of that form data. Traditional HTML inputs, they maintain their own internal state within the DOM itself. But a controlled component intercepts that. You bind the input's value directly to a piece of React state, and then you wire up an on-change event handler.
It honestly reminds me of a micromanaging boss.
Oh, that's a good way to put it.
Think about it. You type the letter H into a text field. The browser wants to just display it natively, but React steps in and says, stop. I have intercepted the H. I am now updating my internal JavaScript memory to include the H.
Right. I need to approve this.
Exactly.
Right.
Now, I will trigger a complete re-render of this component and push the newly approved H back to the screen. It literally needs to see, authorize, and redraw every single keystroke the exact millisecond it happens.
That is a highly accurate way to visualize the event loop interception. And because React is micromanaging that data, the component's JavaScript state is always perfectly synchronized with the pixels on the screen.
Yeah.
But, there is a direct alternative to this micromanagement, the uncontrolled component.
The hands-off boss.
Precisely. Uncontrolled components let the DOM be the DOM. React completely steps back, it doesn't update on every keystroke, and it definitely doesn't trigger constant re-renders.
Okay, so it just ignores it.
Pretty much. It essentially says, I trust you, DOM. Keep track of your own text. React only reaches in to grab the value at the very last second, usually when the user hits the submit button.
You know, I always assumed uncontrolled components were just a sort of legacy anti-pattern from the early days of React, or maybe just a lazy way to build a quick prototype. But to pull that data out without a state variable, you have to use a ref, right? Like the useRef hook.
Correct. A ref is fundamentally just a plain JavaScript object with a current property. The crucial detail here is that its reference in memory doesn't change across renders.
Okay.
You attach that ref directly to the DOM node, and it acts as an escape hatch. When the form submits, you just ask the ref for, ref.current.value.
So if I'm looking at a sprawling, scalable project, how do I actually choose between the two? Let's build out a sort of structured table approach here to contrast the state management differences, like an audio checklist.
I like that. Let's do it.
Okay, category 1. Boilerplate code. Which one wins?
Uncontrolled wins that one, hands down. Less code, you don't need useState, you don't need on-chain handlers, just drop in a ref and you're done.
Right. Category 2, features.
Controlled wins, because a controlled component updates on every keystroke, It enables instant live feedback.
Oh, like conditional formatting.
Exactly. Or if you want to disable a submit button until a password meets a specific regex pattern, or you need instant inline validation. Controlled components are really the only viable path for that.
Makes sense. Okay, category 3, performance. What if I have a massive data entry grid? Say, an internal enterprise tool with a form that has, like, 500 inputs. Isn't React re-rendering every single keystroke going to absolutely tank the frame rate?
Yes, and that is the exact scenario where the uncontrolled pattern shines. In a massive form, those constant re-renders can bottleneck the main thread. It makes the input feel super laggy to the user.
Right, nobody likes typing and seeing the letters appear a second later.
Exactly. Because uncontrolled components completely bypass React's virtual DOM diffing during typing, they maintain native browser performance regardless of how complex the page gets.
That's a huge point. Okay, final category in our table, testing and debugging.
Controlled wins again.
Yeah, I'd imagine. If your data is centralized in React state, you can use React Dev Tools to inspect the exact state of the app at any given millisecond.
Exactly. You can even utilize time travel debugging. With uncontrolled components, the data is just sort of hiding out in the wild west of the DOM until submission.
So if we're providing a checklist for developers choosing between these patterns for scalable projects, what's the verdict?
The overwhelming consensus in the source notes is to use controlled components by default.
Because of the predictability.
Yes, the predictability, the easy unit testing, and the centralized state far outweigh the minor boilerplate costs. You only really fall back to uncontrolled components when you hit severe, measurable performance bottlenecks and highly complex UIs.
Okay, so we've got our forms under control. But once you build that perfect, complex, controlled form with all its validation logic, you inevitably run into the next major architectural hurdle. How do we reuse that logic across the application?
Right, because copying and pasting that validation logic into 10 different components is a guaranteed way to introduce bugs.
Oh, for sure. If the validation requirements change, you have to hunt down every single instance and update it.
And you will miss one.
You always miss one. So, to solve this, we have to look at the historical evolution of React design patterns, starting with the classic higher-order component, or HOC. I find HOCs fascinating because, well, they aren't actually components at all.
No, they aren't. They are purely functional composition. A higher-order component is a function that accepts an existing component as an argument, and then it returns a completely new, enhanced component with additional behavior injected into it.
Let's ground this with a real-world scenario. Imagine you have a legacy application and you have a simple dashboard component, but you only want authenticated users to see it.
A very common requirement.
Right. Rather than putting the authentication check directly inside the dashboard, which tightly couples the logic, you use an HOC called, say, with auth.
So you pass dashboard into the withauth function.
Exactly. Inside, withauth checks the browser's local storage or a global store for a valid session token. If the user is verified, it renders the dashboard. If they aren't, it immediately redirects them to the login screen.
And the architectural genius of this pattern, well, at least at the time, was its adherence to what we call the pure rule. A well-designed HOC never mutates or modifies the internal code of the component it wraps.
It's basically a protective shell. It handles the heavy lifting of the logic and then just passes down the final data as props to the original untouched dashboard component.
Precisely. The underlying component remains completely unaware of the authentication process. It just receives the props it needs to render. And, this was the gold standard for years.
Right, like real-world examples. Redux used to inject global state. React Router used with Router to inject navigation props.
Styled components used with theme. It was everywhere.
I totally get why it was the gold standard, but I have to push back here on the reality of scaling this pattern. Because if I'm building a robust dashboard, it doesn't just need authentication.
Yeah.
It probably needs access to the router. It needs the global styling theme. It needs data from an API client.
Yeah.
If every single one of those requires a wrapper, am I just creating a giant nesting doll mountain of wrappers?
You hit the exact architectural flaw that forced the entire React ecosystem to pivot. We colloquially called it wrapper hell.
Wrapper hill.
Yeah. When you opened your React DevTools to debug an issue, you wouldn't just see your dashboard. You would see a with theme, wrapping a with router, wrapping a connect, wrapping a with auth, wrapping your dashboard.
That sounds like an absolute nightmare to navigate. And beyond just the visual clutter and the dev tools, doesn't that introduce a massive risk for prop collisions?
Oh, absolutely.
Because if the routing HOC and the data fetching HOC both happen to pass down a prop, arbitrarily named data or id, The inner component is just going to receive whatever the very last wrapper decided to send. It would silently overwrite the props.
Which leads to bugs that take literally hours to trace. You're hunting through layers of invisible structural hierarchy, trying to figure out where a piece of data mutated. And that exact frustration is what drove the creation of custom hooks.
The great paradigm shift.
Yeah.
I want to walk through the mental process of refactoring a legacy HOC pattern into a modern custom hook. Let's outline a step-by-step process for this, because it's not just a syntax update, it's a total inversion of control.
It absolutely is. With an HOC, the logic wraps the component. The component is just a passive recipient of whatever the HOC decides to pass down. But with a hook, the component is in charge.
Okay, so step one in our refactoring process, we take our legacy with auth HOC and we extract all that token checking logic. We pull it out and put it inside a standalone function called useauth.
Right, that's your custom hook.
Then step two, instead of wrapping our dashboard from the outside like a nesting doll, we go inside the dashboard component itself.
You delete the wrapper entirely.
Yeah, delete the wrapper. And inside the component, we simply call const user useauth.
And instantly, you've eliminated the structural nesting. Both patterns serve the exact same purpose, extracting and reusing stateful logic, but hooks achieve it without altering the component tree whatsoever.
The best analogy I have for this is looking at a factory worker who needs to reach a really high shelf. Using an HOC is like forcing that worker to climb inside a giant, clunky mech suit.
That's a vivid image.
Right. Like, yes, the mech suit gives them the height they need, but it takes up a massive amount of physical space on the factory floor. And if you also need them to lift heavy boxes, you have to build an even bigger mech suit to go around the first one.
Which is your wrapper hell.
Exactly.
Yeah.
Custom hooks, on the other hand, are like giving that exact same worker a modular tool belt. Oh, you need to reach a high shelf. Here's an extending grabber tool. You need to lift a heavy box. Here's a back brace.
You just hand them the specific tools they need.
Yeah. The worker stays the exact same size, but their capabilities expand endlessly.
That is a phenomenal visualization. The tool belt approach completely flattens the architecture. And when we discuss how these patterns affect long-term project maintainability and clean code, a flat component tree is the holy grail.
Right, because less nesting means a cleaner file.
Exactly. It means you can look at a single file and immediately understand exactly where its data is coming from without having to trace it up through 5 layers of abstract wrappers.
But I want to dig into the mechanical performance impact of this. We know hooks make the code cleaner for developers. But does stripping away those HOC wrappers actually make the app run faster for the user under the hood?
Yes, it does. And to analyze that performance impact, we have to look deeply at how React handles reconciliation and the virtual DOM.
Right, because React isn't directly manipulating the browser's DOM every time a state variable changes. That would be computationally disastrous.
Exactly. The browser's real DOM is inherently slow to update. So React maintains a virtual DOM, which is essentially a lightweight JavaScript blueprint of what the UI should look like.
Okay.
When a state change occurs, like a user typing in our controlled form from earlier React generates a brand new virtual DOM tree.
And then it has to figure out what actually changed between the old blueprint and the new one.
That is the diffing algorithm. React uses a highly optimized heuristic algorithm. It traverses the 2 trees simultaneously, comparing element types and keys. Once it pinpoints the exact differences, it calculates the most efficient way to apply only those specific changes to the real DOM.
It's like editing a rough draft of a massive 1,000-page manuscript.
How do you mean?
Well, if you find a typo in chapter 4, you don't throw the entire manuscript into the incinerator and print a whole new book.
Right, that would be terribly inefficient.
You just take a red pen, cross out the misspelled word, and swap in the correction on that one specific page.
That's exactly the goal of reconciliation. But here is where the wrapper mountain of HOCs becomes a mechanical liability. Every time you add an extra component, even an invisible HOC that renders no actual HTML and merely passes props, you are injecting another node into the virtual DOM tree.
Oh, wow. So the diffing algorithm actually has to traverse all of those invisible layers.
Yes. The deeper and more nested that tree is, the more memory React consumes, and the longer it takes to execute that diffing traverse. By refactoring to hooks, you are physically removing nodes from the virtual DOM, allowing the reconciliation process to run much leaner and faster.
Okay, so that performance impact is very real. And this desire to keep the component tree radically clean and flat extends beyond just logic reuse, though. I noticed the source notes heavily emphasized React fragments as well.
Fragments are a critical tool for DOM hygiene. I mean, it is incredibly common to have a single component that needs to return multiple sibling elements.
Yeah, like a simple article component. You want it to return an H2 for the title, a paragraph for the date, and another paragraph for the content. But React has a strict rule. A component function can only ever return one single parent element.
So historically, developers would just wrap those three elements in a standard div.
But based on everything we just discussed about reconciliation, that arbitrary div adds a completely useless node to the virtual DOM. It's just bloat.
It is memory bloat, yes. But the impact of arbitrary wrapper divs goes far beyond React's internal diffing speed. It directly interferes with the browser's native layout engines.
Oh, wait. Like CSS Grid and Flexbox.
Exactly. Modern CSS layouts rely entirely on strict parent-child relationships. If you have a highly tuned CSS grid container, it expects its direct children to act as the grid item.
Right.
If you inject a useless wrapper div just to satisfy React's return rules, that useless div suddenly becomes the grid item.
And your entire intended layout collapses in on itself. The browser tries to apply grid properties to the wrapper instead of the actual content. That is so frustrating.
It is. But fragments solve this elegantly. By wrapping your elements in fragment tags or, the shorthand empty angle brackets, like you satisfy React's requirement for a single parent, but React knows not to render anything to the actual DOM.
Nice.
The sibling elements are inserted directly into the tree, preserving both memory and your CSS layouts.
Okay, so the golden rule of React architecture seems to be fiercely protect the integrity and flatness of your component tree. Use hooks to avoid invisible wrapper components, and use fragments to avoid useless DOM nodes. But what happens when you hit a scenario where you absolutely have to break the tree?
What kind of scenario?
The classic front-end nightmare. The modal window.
Ah, yes.
Let's say you've built a perfectly clean, deeply nested component tree. Way down inside your dashboard, nested inside a user profile widget, you have a button that opens a generic modal. The problem is, if you try to render that modal's HTML right there in the deep component tree, it gets trapped by the CSS of its parent containers.
Yes, that is a huge headache. If any parent div in that lineage has a property like overflow, hidden, or even a specific z-index context, your modal will get chopped off or hidden behind other elements. You cannot guarantee it will overlay the entire screen.
So mechanically, the modal's HTML needs to live at the very top level of the document, usually right before the closing body tag, completely outside the React root. But logically, its state, whether it's open or closed, the data it displays needs to remain deep inside the user profile widget. How do you reconcile that?
The architectural escape hatch for this is a feature called portals, specifically the reactdom.createPortal method. A portal allows you to take a React child element and physically teleport its rendered HTML into a completely different DOM node.
So you basically tell React, hey, keep managing this modal component from down here in the dashboard logic, but when you actually draw the pixels, render them way up at the top of the browser's DOM.
Exactly. It completely sidesteps the CSS trap because physically, the modal is no longer inside the parent container that has overflow hidden.
But how does React maintain the logical connection if the element is physically somewhere else? Like if I click a close button inside that portal, does the event still communicate with the parent component?
It does, and the how behind that is one of React's most brilliant engineering feats. It's the synthetic event system. React doesn't actually attach native event listeners to every single DOM node. It attaches a single master event listener at the root of the document. When an event fires, even inside a portal, React intercepts it, wraps it in a synthetic event, and manually maps it back onto its own internal virtual DOM hierarchy.
Wait, that is wild. So even though the modal is miles away in the actual browser DOM, React's synthetic event bubbling ensures that an on-click event inside the portal will still bubble up to the logical parent component in the React tree.
It creates a seamless illusion. It physically moves the element to make the browser's layout engine happy, but logically keeps it exactly where it belongs to make React's state management happy.
That is a phenomenal compromise. All right, we have covered some serious ground today. Let's recap the core takeaways for you.
Sounds good.
React is an incredibly unopinionated library. It hands you the tools, but you have to make the architectural choices. When it comes to managing the boundary of user data, you can strictly control your forms by intercepting the event loop and keeping state in JavaScript. Or you can leverage uncontrolled components and let the DOM handle the memory.
And when you need to scale that logic across your application, you have a distinct choice in composition. You can stick to legacy higher-order components and wrap your UI in layers of structural abstraction, Or you can invert control with custom hooks.
Right. Equipping your components with modular tools that keep your tree perfectly flat. Every single pattern we've discussed today, whether it's choosing controlled components for easy debugging, refactoring HOCs to custom hooks to flatten the tree, utilizing fragments to protect your CSS grid, or teleporting UI with portals, all roads lead back to the same fundamental goal.
Keep your data flow predictable and ruthlessly defend the cleanliness of your virtual DOM tree to ensure maximum performance. And, as you look at your own code bases, applying these lessons to client-side rendering is crucial. But I'll leave you with a final thought that pushes this entire paradigm further.
Okay, let's hear it.
We just spent this entire session agonizing over how to efficiently bundle and ship logic like hooks and state to the user's browser. But with the rapid rise of React server components, the new architectural frontier isn't just about flattening the client-side tree. It's asking whether that complex logic needs to be shipped to the client's browser at all.
Oh, wow. That is a fantastic question to chew on.
Mhm.
What if the most efficient way to manage client-side logic is to actually execute it on the server before it ever reaches the browser?
Exactly.
We will absolutely have to tackle server components in a future deep dive. Next time you look behind the entertainment center of your code base, hopefully it looks less like a rat's nest of tangled wires and more like a cleanly labeled, perfectly routed system. Thank you so much for joining us. Keep building, keep exploring, and we'll catch you next time.